Hey everybody.
Hi.
So everyone's here is excited about data visualization, right? Yeah. What do you think gets us excited? Like, to me, I think of it as just like, oh, we're interacting with data. Like, that's the thing today. Like, we're visually querying information, no longer writing SQL to get access to this stuff. So, also like D3, right? We're at the Bay Area D3 user group. The tools are just amazing. I mean, D3 itself, it's insanely popular. This is from a couple months ago. And on top of it, honestly, it kind of just feels like D3 kind of rules everything around us right now. So like people create some beautiful visualizations, and even better, like it's just amazing when they're interactive. Like if you've seen this piece from the New York Times, I actually have to guess what the distribution of a data set is before I get the information. So it's drawing me in. It's giving me a like my own hypothesis before I get access to the answer. Again, did this feel new to you a couple years ago? Like Mike Bostock would create some random thing and make it. It would make headways throughout Hacker News and all these other sites like Crossfilter. Like this is a huge amount of data that I can query in real time, updating faster than my browser can render, or rendering, whichever way that actually works. But honestly, this stuff is not that new. Like, we've had interactive visualizations for quite a while, and to really showcase this, I have an excerpt here from The Mother of All Demos in 1968 by Douglas Engelbart. He's the creator of the mouse.
Because we say, although the content represents your concepts, there's a structural relationship between that content entities that should represent the relationship between the concepts of human thought.
So, look at this. We've got a node link diagram in the first user interface. The first graphical user interface had this representation of a graph. And if you, I'm going to see if I can scrub through here a little bit. Oh. Let's see. So like the graphical user interface had this as a basis of interacting with the information. It wasn't just lists of things or tables. It had deeply rich visual information that you could represent. But a decade ago, effectively like the web took us back several years because we didn't have a scene graph other than just like put a table here, that kind of thing. So we went from the best we could do, ignoring Flash, was take a div and put an image inside that div and render it to the DOM. So we went from this to something like this. This is what made it feel so new, right? Like all of this information is just insanely dense. Like at the same time, literally the same time, this concept, data science, started coming around. The term big data came around as well. Like the venerated data scientists, they just like create something, showcase a problem that we didn't know we had in our businesses, or solve a problem that was extremely hard for us to solve. And even better, beautiful storytellers would create beautiful works of art that explained what's going on underneath. And it made it much easier for the rest of the teams to understand what's going on. So by now you're asking like, why am I here? What am I talking about? So my name is McCrocklin. I've been part of this community for quite a while. I've helped organize SF data mining since 2011 or 12, I forgot which, and Bay Area D3 user group for quite a while as well. I studied human-computer interaction and machine learning. And right now I'm working at Facebook. We build products using data visualization techniques like this, like I'll be showing you, and some really cool models. We're hiring, so if you're interested, please come talk to me. But that said, like, what is visualization? We've had it since likely, since what I've said so far, the beginning of graphical user interfaces. So a business type might say it's the chart that they press when they go to Excel. An artist might say it's like a new medium for them to just play and figure out ways to question society. A designer might say it's a way of thinking of like letting people analyze information to take actions. A engineer might say it's a way of maximizing the information that you're putting on the page in one single view. At the root of this, though, assuming this loads, let's see. At the root of this, though, there's this concept of, one sec. There we go. At the root of this, though, there's this concept of mapping information to a visual plane. So this is what we're doing when we do data visualization, right? We've done this for a while. Like, we've done it to understand ourselves, looking at our bodies, and also like the world around us. Think about it. If you had to understand the shape of, let's just say, the Bay Area with just your feet, how long would that take? It's immeasurable, right? It'd take you years to figure out. Maybe not even like in your lifetime. But when you ask people what the shape of the world looks like, there's some underlying like distribution there. They have a general vague understanding of the shape of the world and the shape of the continents that we live in. Yes, there's a Mercator projection, which that's popular. But that said, maps have existed for a very, very long time. Cartography is a field that easily predates computing. What have we been trying to do when we do visualization or cartography? To me, I have this theory that like what we're trying to do is boost our understanding about the world around us to make us more aware of the other problems that we can then go solve. And like a couple years ago, or 50 years ago, I guess now, maybe longer, we came up with this thing called a computer. So information and pictures could actually interact with us. And we created this field called human-computer interaction design, user experience. They're all nuanced, slightly different, but effectively there's a lot of similarities. So time and time again, I hear that like the purpose of human-computer interaction or interaction design is about simplicity. The goal for us to build these kind of tools is to make things simple. So this is the user interface. If for every product that has come out of Silicon Valley, if that is the claim that what we're trying to do. It's a nice little button that does the thing, and it's even material design and all modern stuff. Obviously, this is not it, right? So when you're going and interacting, like building a new interactive system, what are you trying to do when you're designing that system? To me, the analogy that makes sense is when you're designing a dance between the user and information. Sometimes this dance needs to be very simple, so tons of people can engage and really enjoy the experience. And other times, it just needs to be insanely nuanced, so the user can actually get access and have true understanding of what's going on underlying the data. Again, simple is not the only thing. Simple things should be simple, but complex things need to be possible. So how do we apply human-computer interaction to data visualization? So and the interaction design. So really, there's like three principles that you need to know. There's understanding humans, how we think, how we perceive the world, understanding your users, and what they need. So let's try to get an understanding of who how we perceive the world. Have you ever heard of Weber's law? If you've ever taken a psych class, you might be familiar with this one. I'm going to do a little experiment. Tell me which one is louder. All right. What about this time? Maybe you guys have a better hearing than I thought. So maybe this. Let's try this one more time. Okay. See, there's a debate right there. Weber's law defines the fact that you had a debate. It's showing that there's only after a certain threshold, there's a threshold called the just noticeable difference. People can't perceive the information that they're getting. So it's important to know, like the math is here, but kind of ignore it. K is there as a thing to show that it varies from person to person. Some people hear better than others. Some people see better than others. But just noticeable difference is how we is like the threshold on how we perceive the world. So we use this a lot in visualization. This is the underpinning of how we make the designs that we make. How we decide to use a line chart over an area chart or a pie chart over a bar chart if that happens. We have all these visual channels. Position, like figuring out, mapping the position of a point in the plane to, or length, maybe area, and shape. All of these, using Weber's law, psychologists have actually formalized that shape is really useful only for categories, but it's not gonna be useful to see the length or like the amount of something. If you decided to change the shape of a triangle, or like change a triangle is $3 and a square is $4, it's very, very difficult for the user to actually figure that out. But if you switch to using position for quantitative values, or maybe area, it ends up being a lot easier for the user to understand. This is the underpinning. How often have you actually said pie charts suck or some derivative of that? What?
Every day.
Okay. So Ian says this every day. It's proven through Weber's law, and it's only sucks in cases of doing comparisons in between or next or looking at two different pie charts, like 1, 2, 3, 4, and 5. On the pie charts look very similar. We clearly see that there's a difference, some kind of difference. We just can't communicate how that difference is there. But when you look at it on a bar chart, it becomes instantaneous. And this is formalized. This is formalized through Weber's law. I'd like to thank whoever put that on Wikipedia for pie charts. It's pretty good. Recently, Lane Harrison and his team actually used Weber's law to classify different visualization techniques for understanding the process of correlation, figuring out which data set looks more correlated. I won't really go into this paper, but it's proven that this concept, Weber's law, can actually be used for comparisons that are outside of simple spatial reasoning, but actually like a boosted space. So he found that like a scatter plot for positively correlated data ended up being like the easiest thing for people to understand, which I found to be interesting. With that said, we're here to talk about interaction, right? Fitts' law is what I like to think of as it defines the ratio between the distance and the size of an element from the cursor or a pointer that the user is interacting with, and trying to get to that specific point. I can, like, this math is something you probably don't need to know, but you need to understand the concept. It's honestly like the kerning of interaction designers. Once you see it, you just see bad everywhere. I'm gonna ruin your day as well. Notice the distance between C and E.
Yes.
It's the same thing when you go onto a random web page that has, for some reason, a close button sat right in the middle of the page. Like, everyone's eyes are screaming right now. And, like, I'm trying to click here. This is an actual link. And for some reason, because links in certain browsers actually work that you have to hover over the text, this text is smaller than my cursor can allow me to even, like, hover over. So it helps us design systems to move into a direction that makes a lot more sense. Moving the close button to a position to the top left or the top right, because no matter which way the user's cursor is moving, they can interact with the point, because there's no error to moving that far to the left, or like just clicking a button instead of a link. How do we apply this to visualization, though? Like, let's think about the most common visualization. I just did it right there. What do you do when you want to interact with a bar chart? Like, what makes sense? Like, if I'm a user and I'm trying to interact with a bar chart that can't be seen, so let's move to the pie chart. The pie chart. How am I going to get it? Like, the details of this pie chart? Yeah, exactly. You hover over it. So what happens when the pie chart has a value? Let's see, can I update this?
Very small.
That's very small.
Over the legend.
Oh, good. Good catch. Sometimes they don't actually do that. In this bar chart that you can't see, the invisible chart.
On the left-hand screen. On the left-hand side.
Oh yeah, you can see it over there. You can see how, like, I have to interact with these points, but I have to actually, like, interact with the entire with the actual value. So if it's small, I have to spend a ton of time to accurately get to that 5. That was designed actually by a designer. This one was built by an engineer. The same concept applied. Does this make sense though? Like, if I'm going to interact with a bar chart, does it really make sense that I have to hover over that point? Like, hover over the area of the chart of the bar? To me, I don't think so, because what are bar and line charts really designed to do? They're designed to show variance in one dimension by another dimension. So you're typically querying you want to get access to a specific point based off of the x dimension. So if you apply that technique, or if you think of that in that way, then you can actually build a visualization that'll remove the y-axis from the interaction, so the user only has to interact with the x-axis to get access to understand what's underlying. And to prove that this is not just some random block, this has been done on the New York Times. They did this for this interesting visualization that they have a angled bar chart that is also invisible.
Yeah, that's good.
Line charts. So many times I've seen this, and it annoys the heck out of me. you're giving your user the distribution of values over x and by y for y, and you're forcing them to go and click or like hover over a 1 pixel line that varies by both dimensions. So I have to must move my mouse all the way around in order to get access to the information. Apply that same concept, do an x value mouse over, and the interaction is much, much more fluid. This makes Fitts law effectively no longer a problem for the visualization because the interactive area is so large. What about things that are a little bit harder to deal with, like scatter plots? Because they actually vary 2 dimensions, x and y. If we're going to interact with that point on a scatter plot, like we've got a 3 pixel point that I was luckily able to hover over. How do we, how actually do we do this at scale, in this visualization? So there's this technique called a Voronoi. There's d3.geom.voronoi is a plugin or like a layout that you can use to derive a set of points that are closest to the point that you want to interact with. A Voronoi is a little complicated. It's a mathematical concept. So a Voronoi partitions an area into cells based off an initial set of points called seeds. Seeds would be the points in the scatter plot, and it's the cells are the collection of points that are closest to that given seed. So looking at this again, when I hover over this cell, I get Equator New Guinea, which is this small little yellow point right there. So removing that layer, the user can easily interact with this. And it's pretty awesome, and it makes interacting with these tooltips much more fluid. But to me, this right here has always felt odd. My cursor is over here. I have no idea what's going on. Why is Equator Guinea like something that I'm interacting with? Thankfully, in 2005, a couple guys felt the same way. They designed this thing called the bubble cursor. A bubble cursor actually replaces the mouse in a given area on your application. And what it'll do is show you the closest point that you can interact with on the plane and give you insight into how far away it is. So Fitts law defines the size of the point and the distance from your cursor to that point. So this is actually, the bubble cursor is defining Fitts law to you in real time as you're interacting with the information. So you're no longer bounded by the data that you're actually displaying. This probably won't work on that screen, or maybe even that screen. Let's see. I tried de-emphasizing the cursor a little bit to make it easier to see on a desktop. Oh, you can see it. So
that highlighted area is that's what we call the bubble cursor?
Yes. Yeah. The darker area in this example is the bubble cursor. So you could actually just remove the cursor, but I kept it there for simplicity. These techniques don't just apply to line charts or bar charts or a scatter plot. They can be layered and can be used across every visualization technique that I've seen in a block or on the web. Take a look at this example. This is a force layout, and what it did was actually extended the area of the points to make it easier for a user to click with their fingers, but also realized that that's going to kind of constrain the layout. So what they did was build a Voronoi that made it much easier for the user to discern what point they're actually interacting with. So these techniques apply to every visualization that you're building. we talked about Fitts' law and Weber's law, but in human-computer interaction, there's a ton of other stuff. Gestalt principles, Elijah Meeks has a good talk about it. Change blindness, rule of thirds. There's a ton of things to learn. So that if you're interested, I can dive into that afterwards in questions. But that said, honestly, knowing what humans like how humans perceive the world is really important, but honestly, knowing your audience is way more important. Like, you need to understand who you're building this for. This is an example of somebody who did not know their audience. What did they do? At best, they went to the person that this was built for, got the list of things that they said they wanted, put the list of things that they wanted on a page. Okay, so I go to this dashboard once, see it. Maybe I go 4 months from now and see it again. That's at best what I'm doing when I view this kind of thing. Same thing applies if it's pretty. Like, it doesn't have to be designed in Salesforce. It can be designed or some other platform. It can be, like, this was actually made by a designer, but none of these data points made any sense. They put random numbers and pretty charts on the page, and I don't know what the heck I'm looking at. So, like, there's ways to really get at your audience. There's roles dedicated to this. You can go and talk to them and figure out not just what they want, but what they need. You can take that and digest it, get some concepts of like personas around the people, the product you're building, or you can do A/B testing. Honestly, though, there's a ton of conferences out there for this. Talk to your designers, talk to your product managers. This is a very important part of building product. And honestly, I would say that it's not just their responsibility. If you're tangentially related to building product, you should always care about knowing your audience and knowing who is this for. But how does this actually apply in the real world? Again, like, you're never the user. Again, ask your customers questions or know your readers if you're doing data journalism. But how does this apply? Like, take this visualization by Mike Bostock and Shannon Carter. They really knew that the majority of the questions that people were having is, who's going to win? Who's going to win in what scenario? There were so many different paths that people could take. Tons of different ways that Obama could win. Tons of ways that Romney could win. But eventually, it boiled down to a couple different questions. And after 1 or 2 clicks, you found out who the winner was. So they knew they knew the audience because they knew that their readers were caring about the politics, because this is the politics aspect part of the New York Times. They also knew that that they were inundated with tons of people saying, "Oh, what happens if this happens? What happens if this happens?" And like hearing that over and over and over on tons of media sources, you get lost in what's going on. Giving the user the ability to answer that question for themselves was pretty great. But honestly, the thing that I found most interesting about this is they knew exactly what the user needed. They didn't build a visualization that was completely tangential to this question. They didn't try answering a different question. They only focused on a relatively simple question: who wins given these swing states? Expository visualizations like that one kind of have an advantage here, right? They're tailoring their experience off of a small data set and creating great visualizations where they already knew the data. They probably spent a significant portion of time before they even built a visualization, understanding what the underlying data looked like. And like if you take a look at this example, I find this pretty interesting because it applies some of the same techniques we talked about, Fitts law. It prevented the user from interacting with all of the different circle packing layouts, only showed the first layer, forcing them to hover over to click to see the details, and then from there figuring out which one they want to interact with. But how does this apply to like take this other example that did not load right. So let's see. So take this other example. They walk the user through a story in one of the lightest interactions I can possibly think of. This is kind of being popularized as scrolly telling, right, Ian? You're taking them through the questions that you found to be very valuable. The thing that I love about this visualization, though, is once you're done, they open it up. They let the users ask the questions that they care about as well. So you can group by truck for some reason, and then color by game, which is interesting to see that trucks are getting more and more popular, actually. So I'd like to look at something that's a little bit more exploratory. Most of the time, people look at products like this, and they're like, okay, it's a beautiful product. But let's look at this from a visualization lens. We've got, if you can see it over there, there's actually a bar chart showing the distribution of the price in the price ranges. You've got a map, again, a visualization, and a bunch of different filters. This is common for visualization, and common for products today. Yelp has this. A bunch of products like Airbnb have features like this. So this is a great and beautiful exploratory visualization. They knew their audience, right? They figured out that some of the most important things was where it is and what it looked like. I'm kind of confused about Taj Mahal in the middle of SF. But that happens from time to time.
It's a hotel.
Does anyone want to just take a second to figure out what's going on here?
Daily City? Someone messed up their Airbnb.
Okay, that.
That's a Daily City, no.
Well, that was an amusing one. Okay.
So good. Obviously, you don't want to show the front of the house.
I think Margaret swapped with Daily City somehow.
So, that said, let's think back to something that's more classically a visualization problem. We just talked about scatter plots and how to use a bubble cursor. Honestly, though, when you're throwing two quantitative values to compare the distributions, do you really want to show that and force the user to look at one specific point? Or do you want to show how the distribution varies by group, by clustering them together? Maybe you actually want to just say, look at a specific cluster and see how that relates to the rest of the system. Making sure that you think about the interaction as part of the process that you each step of the way when you're building visualizations is extremely important. So we covered some HCI principles. We talked about how knowing your audience is really important, knowing what use cases they have. But lastly, I'd like to say, just please know when to break the rules. Sometimes it is useful to have a pie chart. And after, what I hope you take away from this is like, let's get that image, like get that chart out of the div that we put it in several years ago, and make it part of the web. So, thank you. Questions?
I have a question. I know you're at Facebook, and I know that React.js is getting pretty big, which is the front-end framework at Facebook that I think is taking over Angular. Someone came out with a book for D3 and React. I'm not sure if you've gotten a chance to look at it, but I was wondering if you had thoughts on that. And
I do. I use it. I use it a lot. Yeah, we do a ton of React and D3 at Facebook, specifically my team. I have not seen the book. I've seen a lot of other ways that people are working with React and D3. Most of the times that I see React and D3 actually being used together, the way that they use it, they ensure that D3 handles the rendering and React handles the application management. And the only real reason that exists today is that what's going on there is React its biggest shortcoming right now is transitions, and D3 with the the data join API makes transitioning just a breeze. So people are choosing to use D3 for rendering right now. If and when we solve the problem of transitions in a way that meets the needs of D3 developers, we'll likely see a movement towards using D3 to handle layout and handle binding scales and things like that, and have React handle all the rendering. So
I really appreciated all of those examples of the different interactions, and some of them I hadn't actually seen before. And they'd be techniques I'd want to reference. Is there any way that you can compile the blocks that you showed in a way that I can get to later?
Yeah, I'll post them on the meetup. Yeah, I've got them all ready to go.
Cool.
So
you spoke about interactions and having filters and checkboxes on the data visualization. Now, what happens a lot of times is the users would ask that we want to slice the data by this category, we want to slice it by this, so slice by 15 different dimensions. So what is that point where interactivity is an overkill? Because eventually the user is going to get overwhelmed after a point. So till the point, I think it's very useful.
So this is a really, really great question.
Can you actually repeat the question?
Yeah, sure. I'll repeat the question. So what happens when you constantly get, well, can I filter it by this? Can I filter it by that? Can I filter it by this? You end up having 500 different wants from your users to filter. One, it's knowing your data, knowing what kind of cuts make sense. So knowing when to say no is, I'd say, one of the most important things. But the other thing that I think is it's just ensuring that the design tailors to the visualizations that matter most. So price range, they actually spent, I'm sure that's a really hard problem to get that kind of distribution in real time, because as I hover around, it does update in theory. Yeah, it did update. That's a pretty hard problem from an engineering standpoint. But other things, if I go in here and get the other list of potential filters that could be applied, were completely de-emphasized. You didn't need to have it there, but people had that question. So there's a way to weight the importance, from a visual perspective, that helps helps the user focus on the main task at hand while still supporting the functionality that maybe expert users might want. So. Is that it? Okay, thanks.
I just wanted to make a comment about pie charts and know your users. So pie charts are except when certain times when you're in a game kind of environment where users are playing against each other. You don't want them to totally get demoralized and they are like up in the air. How much am I losing or winning?
Mm-hmm.
So in that scenario, it's pretty good. To keep it muddy.
I think so. Actually, I am more of a fan of pie charts than most data viz people, simply because there are scenarios that
there are actual scenarios like this.
Yeah. Also, just looking at two different data sets, like 2 different points, like male versus female. It's very useful to probably put that in a pie chart distribution. Interaction gets pretty tricky with radial visualizations. Like if I had a good example for pie charts interaction, I'd show one, but it's a hard problem to think of for Fitts law. But we'll see where that goes.
Just wondering, do you have any thoughts about like interactions for constructing visualizations? Because like a lot of the examples you showed, well, all of them I think are like constructed by developers. You know, they're hacking away at some JavaScript or something. And like the closest UI, so when I think of UIs like in Excel, the chart builder, you select the chart type and you go through, configure it, and then there's Tableau where you can drag and drop columns. So like, do you have any thoughts about sort of the ideal UI for constructing the visualizations?
I think we have a long way to go to really figure out what that ideal is. I don't feel like we're exactly where we should be today. So if you look at Tableau, Tableau takes, let's, from a programming standpoint, Tableau is kind of like the functional paradigm, and Excel it takes the object-oriented paradigm, top-down versus bottom-up. And like I find like a bottom-up approach really works well with visualizations. But that said, do you really even need to define the visualization? Could we just support that and show that to you? There's some great talks by Jeffrey here and showcasing a bunch of work from all of his students that they're showing like recommendation engines that recommend different visualizations and based off the distribution you have or the data you have. Like those kind of experiments and some of the other things that are coming out today in labs and in like industry will likely be the next thing that we start seeing for that problem. So. Thank you.